Welcome back. We're going to continue on with the 2014 AP exam. This is question number 5 on the AP, and this is our area volume. Now remember, this is a non-calculator question, and we can tell that because of the number. Questions 3 through 6 will be non-calculator. So this says, let R be the region between the following functions, y equals x e to the x squared and y equals negative 2x. And the vertical line x equals 1 as shown in the figure. Now they're asking us to find the area of region R. So to find the area is not really a hard thing to do. We're going to use our famous rectangle of mathematics. So to find the area, I'm draw my rectangle over here. And if I look at this rectangle of mathematics, it's going to have a thickness of dx. Now because it's a vertical rectangle, we're going to keep our function in terms of x. Remember, so for a vertical rectangle, we are in terms of x. Horizontal rectangles, we're in terms of y. So what's nice about keeping it vertical in this case is because everything's already in terms of x. Whoops, sorry about that. So we're going to go top minus bottom. That's our rule. Top minus bottom. So really what I want to do is I want to find the area of this really tiny rectangle. And if I can find the area of this rectangle, I can extrapolate that to the entire function, the area between the two functions here, because I can use my integral to find the area as we let the rectangle go between 0 and 1, and it kind of fills in our area. Well, the top function is just our x e to the x squared minus, and the bottom is this negative 2x. So if we want to find the area, it's going to be the integral from 0 to 1 of x e to the x squared plus 2x dx. Now we're going to have to solve this one, but if you don't, I mean, you're going to be okay. I mean, you're going to get 1 point for writing this out. So even if you don't remember how to integrate this one, you're going to be okay. You'll still get a point, and you can still even get 2 points if you forgot how to integrate this problem. You just want to do the best you can. But this is not too bad. We are going to use u substitution, where u is going to be x squared. My du becomes 2x dx, or dx is du over 2x. So these x's will cancel, and what we're left with for our new integral is the following. This becomes 1/2, and I'm not going to replace my domains just yet. Whoops, let me just write it this way. Let me kind of mess that up here. There we go. Put the 1/2 inside. 1/2, remember that cancels, e to the u plus 2x dx. Now this is kind of weird to write it, because remember this is really in terms of u right there. That's really a du. So when I integrate this one, we're going to get 1/2 e to the u. The antiderivative e to the u is e to the u, but e, and I'm going to replace it with my u, which is x squared, plus, and then this becomes just 2x squared over 2, which is just x squared. And we evaluate this from 0 to 1. So our antiderivative here would be worth 1 point, and then using the fundamental theorem, or FTC, remember f of 1 minus f of 0, plug in the 1, we're going to get 1/2 e plus 1, plug in the 1, minus plug in the 0, e to the 0 is 1, so that's 1/2 plus 0. And you can leave your answer like this. And that is another point for us. Look at that. We got 3 points already just for one question. 3 points, and this took like less than 5 minutes. All right, now for part B, this is where it gets a little bit more fun for us. Write, but do not evaluate. My favorite phrase in all of mathematics, do not evaluate. An integral expression that gives a volume when the region is rotated around the horizontal line y equals negative 2. So down here is the line y equals negative 2. And we're going to revolve this around it. So if you notice, when we look at our rectangle of mathematics here, we are going to get our washer if we were to revolve all of this. We would get our washer method. So I'm going to kind of take a look at this real quickly. If my washer, so when I draw up my washer, it's again vertical, so we're going to be in terms of x. It will have a thickness dx. There's the line y equals -2, and we're going to get the radius of the outside function. Well, the outside, remember, is the furthest from our axis of revolution. So there's our outside. And if you notice, this is at e to the x squared minus a -2. So this is going to be x e to the x squared minus a -2. My inside radius, that's the hole. That's the part, that's this little dashed part right here. There's my inside right here. And this top is -2x minus -2. So the radius here is going to be -2x minus a -2. Remember, radius is always the distance to the axis of revolution. And that's how we got those. So of course this becomes x e to the x squared plus 2, -2x plus 2. And now when I want to find the volume, ready? Now remember, volume of a washer is going to be pi r squared h. So we're going to do the volume, whole volume is going to be the volume of the outside minus the volume of the inside. And I can write this as a single integral. Pi, my integral is going to go from 0 to 1. I want the radius of the outside function, which is this x e to the x squared plus 2 squared minus the radius of the inside, which is -2x plus 2 squared dx. And there's our answer right here. Very easy to do, does not take very long. Now how do you get this? You can get +1 for the limits and the pi, and this whole part right here is worth 2 points. So again, we're at 6 points and we've only been about 7 minutes. So these don't take too long for us, hopefully. Alright. For part C, let's see here. Again, it says write but do not evaluate an expression to get the perimeter of our function. Alright, so remember, perimeter is always the distance around an object. So if we take a look here of R, we're going to have 3 distances. We have the x e to the x squared, the line y x equals 1, and the line y equals -2x. So if I kind of look at those again, right here, here is x e to the x squared. This is x equals 1, and down here is y equals -2x. So I need to find each of their lengths right here. So I can do that. Now, for the function, remember distance formula? For a non-linear function, the distance is the integral a to b of the square root of 1 plus f prime of x squared dx. So they want you to use that formula right there. So I know I'm going to need the derivative. So if I know y equals x e to the x squared, I know I'm going to need its derivative. Y prime would equal, product rule here, the first times the derivative of the second, 2x e to the x squared, plus the second e to the x squared times the derivative of the first, which is 1. Cleaning this up, 2x squared e to the x squared plus e to the x squared. Alright, so I'm going to get these. So I got 3 parts you have to worry about, and 3 parts here. So we'll call this part A, B, and C. So to get the perimeter, then we're going to take parts A plus B plus C. So let's do part A. Part A is our exponential function here. So to get that perimeter, it's going to be we have to use our formula here. And remember, we're integrating from 0 to 1, the square root of 1 plus our derivative that we just found squared. 2x squared e to the x squared plus e to the x squared squared dx plus, there's a, b is my line right here. So to get to get this line right here, I just have to find out what this distance is, and that's just top minus bottom. So the top, if I plug 1 in, is just e. The bottom is going to have a distance of 2. So this distance right here is just e plus 2. So plus e plus 2 plus, and now this distance right here. Well, how do I get this distance? Well, I can even just use my formula if I'm really lazy. I can use my formula, or I can use, I know this is 1, so that this is 2. And I can use Pythagorean theorem to get this as square root of 5. But I'm going to be lazy. AP doesn't care. I don't care. 0 to 1, the square root of 1 plus, well, if y is negative 2x, the derivative is negative 2. So 1 plus, and that becomes just negative 2 squared is 4, and again you get the square root of 5 dx. And they tell you not to simplify, so I would just leave it alone. So how many points would this be worth? Well, if you took the derivative, 1 point. The integral part here, 1 point. And the entire answer together, knowing to add them all, priceless, 1 point. Alright, so that's question number 5 for us. Come back, we'll take a look at question number 6. See you then.